So good afternoon. We're going to do a lesson on lines today. This is the last lesson in Unit 1. So in this assignment, we're going to study two variable equations. And the one we're going to study this time is going to be what we call first degree equations. And when we do this, you're going to recognize that their graphs are going to be lines. So when we talk about two variable equations, basically these are what we call input-output equations. So when we get into Unit 2, these two variable equations are going to be called functions. And what's going to happen with functions, they're going to have this input value, which we denote as x. They're going to go through a series of calculations, and that result is going to be an output value, which we denote as y. So in our lesson, there's going to be three views that we'll be studying. The first view is going to be the equation form. So we're going to be looking at equations in the form of y equals mx plus b. So this is going to be a first degree equation, and it's also called a linear function. The other view we're going to look at is what's called the table view. Yeah, we're going to use big T. And what it's going to do is it's going to organize our solutions as ordered pairs. So we're going to have this x coordinate and this y coordinate. And yeah, we're going to be using those to graph. So that's the third view. The third view, of course, is the graph. So the solutions will be drawn on as a graph. And then what we'll do is we're not going to find all the solutions. We're only going to find a few of the solutions. But the graph itself is going to form the solution set. And what we'll discover is the solution set is going to take on the shape of a line. So for us, as we move forward, an example of a linear equation is going to be this y equals 2x plus 1. So that's going to be one of the views that you'll see quite a bit as an equation. We like to have them solved for y. It makes them a little bit easier to deal with. So again, there are a whole lot of solutions to identify. What we're going to do is identify at least two solutions. A third helps to see the pattern. So when finding solutions, we're going to pick easy values of x that will go through the calculations. And notice here, we're going to be multiplying by 2, and then we're going to be adding a 1. Those are going to be the calculations. And these solutions we're going to place in a table that allows us to have these ordered pairs. So it's going to help us identify these ordered pairs. So the table is going to help us create ordered pairs. So notice that 0 is going to go through our series of calculations. So what we do is we substitute 0 in for x. We have 2 times 0. If we add 1 to that, we still end up with just 1. So when 0 went in, 1 came out. So the ordered pair 0, 1 is formed. If we put 1 into the equation, we have 2 times 1 plus 1. Well, 2 times 1 is 2, plus 1 is 3. So 3 would be my y value. So 1 was my input value, 3 was my output value. So the ordered pair is 1, 3. If 2 goes in, we have y equals 2 times 2. And then we're going to add a 1. So 2 times 2 is 4, plus 1 would be 5. So 2, 5 would be another solution. So 2, 5 would be written as an ordered pair. Again, there's more than these three solutions, but all we have to do is identify a few of them. And so what we're going to do, by listing these ordered pairs in a table, you're going to start to see a pattern develop. Notice looking at the x values, 0, 1, and 2. It went from 0 to a 1. It went from a 1 to a 2. Notice that the x values are increasing, but they're increasing by the same number each time. They're increasing by a 1. If you look at the y values, it went from a 1 to a 3 to a 5. Notice that they also are increasing. And how much are they increasing by? So if we went from a 1 to a 3 to a 5, you'll see that they're actually increasing by a 2. So this pattern is called the rate of change. It is also commonly called slope in linear equations. The slope is written as a ratio. So the rate of change is going to be written as a ratio. The numerator is going to represent the change in the y's, the change in the y values, and the denominator is going to represent the change in the x values. So what we do is we usually write this the following way. In a lot of textbooks, you'll see slope written as this little triangle y over this little triangle x, that's actually the delta symbol. That's delta y over delta x. And what that really just basically means is the change in y over the change in x. So if we want to write the slope of this equation right here, notice that the y is changed by 2. So they increased by 2. And the x changed by 1. So our slope is this ratio of 2 to 1. Now, most commonly, it's written in simplest form as simply 2. But to use slope, it's got to be written back as a ratio of a numerator and a denominator, because the numerator is describing the change in the y values, and the denominator is describing the change in the x values. So if I look at the equation y equals 2x plus 1, again, notice that we can graph those solutions. Notice how we had 0, 1 was the solution. We had 1, 3 was the solution. And we also found 2, 5 as a solution. So what we can do is we are allowed to graph those solutions. So 0, 1 would be located here at this spot. 1, 3 would be located in this spot here. Notice again how you start at the origin, slide over 2, and then up 5, and that locates the third solution. And these 3 solutions are actually lining up, and that's why we call this a linear function. So what we do is we typically draw a line through those 3 points. This is supposed to be a line, so a little nervous on that. So that would be my line that goes through those points. So that's going to be the third view of our function. So we're going to have the equation, we're going to have a table, and we're going to have a graph. So if I look at the equation y equals -2/3 x minus 2, we want to identify 3 solutions. Now, notice since 3 is our denominator, we want to use values that can be divided by 3. So 0 is still a good choice here. It's still going to make this math pretty easy. So I have y equals -2/3 times 0 minus 2. So that's how that's going to still be 0 minus 2, which is still just going to give us a -2. So 0 went in, -2 came out, input, output. Now, since 3 is the denominator, my next number I actually want to pick is 3 because I want to be able to divide it by 3. So I have y equals -2/3 times 3 minus 2. Notice how 3 goes into 3 one time. 1 times -2 is -2. -2 minus 2, that's a -2 and a -2, which makes then a -4. So remember how we use the circle methods. A -2 and a -2 makes a -4. So 3 went in, -4 came out. And also 6 would be another easy number to divide by 3. So I have y equals -2/3 times 6 minus 2. So that's how 3 goes to 6 2 times. 2 times -2 is -4. We have a -4 and we have a -2. That's going to be a -6. So 6 went in, -6 came out. So by making this table, we start to see a pattern developing. If we could, let's describe how the x values are changing. So are they increasing or are they decreasing? It went from a 0 to a 3 to a 6. So we recognize that's actually increasing. Increasing by how much? Is there a pattern? Usually with linear equations, there's this pattern. So notice how the rate of change in the x's, the change in the x's is actually increasing by 3. Now, if we look at the y values, are they changing? I have a -2, a -4, a -6. Is that increasing or decreasing? Notice that they're decreasing. They're going down. So they're decreasing. They're decreasing by how much? We went from a -2 to a -4 to a -6. Notice that they're decreasing by a 2. So we pick up on here, notice the coefficient of x. So if I go back up here to the top, notice that the coefficient of x is actually this -2/3. Notice the top number is describing our change in y, decreasing by 2. That's what a -2 is doing, is decreasing by 2. If you look at the denominator, notice how it's a 3, increasing by 3. Notice the coefficient of x is actually the slope of our line. So m actually stands for slope. And our slope in this problem would actually be -2/3. So what we pick up on as a shortcut, I really don't even have to make a table. I can actually identify the slope by just identifying the coefficient of the x of -2/3. Also notice in this problem, the 0, -2. In our ordered pair, 0, -2. If we graph 0, -2, it would be located down here. Notice that that point is on the y-axis. So this is a special name. It's called the y-intercept. If you look at our equation, if you look at our equation, notice that what the constant was. That constant was a -2. That constant actually represents the y-intercept. So that b was actually this -2. So that describes our y-intercept. So in graphing this line, I actually can, instead of using the table, I actually can use the y-intercept and the -2/3. So notice how I've got this y-intercept graphed. And notice how it's said from there, your y's change by going down by 2, while your x is increased by increasing by 3, and I can make a solution there. So again, notice how that slope again was this -2/3. So once I get to the y-intercept, I can go down 2 and write 3, and that would locate the other solution. So if you look back up the table, notice that we have this 3, -4. If you look at this point right here, it is 3, -4. If I go down 2 again and write 3, I would locate another solution. Notice how that solution is also in the table. That's 6, -6 there. So notice how those solutions are present in our graph. Now, I don't have to put the -2 on the top. I could write this as 2 over -3. So if I wanted to, I could have rose up 2 and ran 3 to the left, and I could have located another solution over there at -3, 0. So if you notice, then we do form this line as our graph. So I can graph the solution as a line. So what we start to pick up on is there are 3 views to deal with, but most often we just recognize the equation, and from the equation, we go straight to the graph and graph it without the second view of the table. So we call this the SlopeIntercept form of a line. Notice how this m is going to represent the slope, and this b is going to represent the y-intercept. So remember, the y-intercept is a solution on the y-axis, and the slope is going to provide us a second solution that will allow us to draw the line. So notice we really only need 2 solutions to sketch a line. So notice how our slope is going to be the -3/4. A lot of times, instead of saying change in y or the change in x, we sometimes use the phrase rise over run. So rise describes a vertical direction up and down, and run describes a left and right direction, side to side. And notice how the 1 is actually our y-intercept. The b is equal to 1. That's going to represent our y-intercept. So again, the slope is going to be this -3/4, and this y-intercept is going to be 1. Or we also can write it as an ordered pair, 0, 1. So either way, 1 or 0, 1. So the slope and the y-intercept can be used to graph the line. So if I go down here to the graph, notice how to graph this, what I do is I just graph the y-intercept first. So I place a point on the y-axis. That's where it's going to cross the y-axis. And then from there, I can use the slope of -3/4. So -3/4 means to go down 3, that would put me at -2, and then go over 4, 1, 2, 3, 4. That would put me at this spot right here. So that's where another solution is going to be. Now, if I wanted to, instead of using -3/4, I could write this as 3 over -4. So the negative doesn't have to stay on top. So from this y-intercept, I could have went up 3, 1, 2, 3, and left 4, 1, 2, 3, 4, and I would have a solution over here. Because notice again, I can't go down 3 and write 4 again because I'd be going off my graph. So from there, we can sketch our graph of our line. So and again, that is just a sketch, if you will. So that's going to represent our graph, just a rough sketch it out. So again, when we do this, notice the slope must start from the y-intercept. So actually we have to graph the y-intercept first before we can use the slope to find the second solution. And that's imperative in graphing these lines. Another thing we may have to do in our homework is you may be given 2 ordered pairs. If you're given 2 ordered pairs, we can use what's called the slope formula to determine the slope. So if we have a 0.1, x1, y1, and we have a 0.2, x2, y2, we are allowed to use this formula that says subtract the y values, subtract the x values. So when it comes to this next problem, given the order pairs 2, -1, and -4, 3, I can find the slope and I can also graph the line. So as far as finding the slope, we use this formula. So notice how I'm going to call the first order pair 0.1, so x1, y1. I'll call the second order pair 0.2, so that's going to be x2, y2. So from there, what we can do is use the slope formula to solve for the slope. So notice how it's going to be 3 subtract what y1 is, and y1 was a -1. And then I have x2, which is -4. And we're going to subtract x1, which is a 2. So remember, we have this 3, and we also have this right here, which really means we have 3 plus 1. And on the bottom, notice how we have a -4, and we have a -2. So it's actually going to be -6. So we have really a 4 over -6. And remember, fractions are supposed to be put in lowest terms. So either use your calculator or just do it by recognizing that there is a common factor of 2 that I could divide out, which is going to give me a 2 over a -3. And again, the negative usually doesn't stay on the bottom. So usually we will write it as -2 over 3 or the negatives out in front, one of the two. I usually put the negative symbol always in the numerator is what I usually do. So that would be the slope. Now to graph this, we have a couple of choices. What I can do is plot the 2 points, or I can plot 1 point and use the slope to locate the second solution. Well, since I have 2 points, I'm just going to plot the 2 points to graph it. So what I have is this 2, -1, 2, -1. I locate that one. And then the other order pair was, what was that? What was that other order pair? I can't see it right now. -4, 3. So -4, 3 would put the solution here. Notice how I can draw a line through those 2 points, and that would be the graph of the line. So that would be a way to do it. Or I could have just plotted 1 point and used the slope to locate a second point. So something you may have to do also on the homework is you may have to write an equation of slope-intercept form. So remember, slope-intercept form is this y equals mx plus b. So to do slope-intercept form, we need to know 2 things. We need to know the slope, and we need to know the y-intercept. If I know those 2 things, then I can write it in slope-intercept form. So if you notice this equation here, we said the slope is 0. So I have y equals 0x. And notice how we said the slope is a -5. So that's plus a -5. So notice how this just turns into 0 plus -5. Or we can just say, hey, we have -5. So the equation in slope-intercept form would be y equals -5 in simplest form. We don't, this would be okay, but since 0 is in front of the x, we can actually drop the x out of the equation, just call it y equals -5. So this is going to actually be a pretty cool equation we may look at further on when the slope is 0. Now, sometimes you're going to be given a slope and an ordered pair. So write an equation of a line whose slope is 1/2 and passes through the point 3, -5. So to do this problem, again, we start with y equals 1/2 x plus b, 1/2 y equals mx plus b. Again, the slope is given, so m is going to be the 1/2, but we still would need to find the y-intercept. And to do that, we don't know what b is, but we do know what x and y are. That's where this 3 and this -5 come into play, because they're an x value and a y value. So what we're going to do is we're going to substitute the 3 in. I'm sorry, we're going to substitute the 1/2 in for m, and we're going to substitute the 3 in for x, and we're going to substitute a -5 in for y, and we're going to solve this for b. So I'm going to have then y equals 1/2 x. I'm sorry, I wanted to substitute in. I didn't do that. Try that again. So the y gets changed to a -5, and that's going to equal then 1/2. I'm replacing m with 1/2 times x was 3, and that's going to equal the, or plus b is what we have there. So what I want to do now is solve for b. Remember, we have to simplify each side of the equation. Well, the -5 is simplified, but I can multiply 1/2 times 3, and that's going to give me 3/2 plus b. And to get b by itself, notice how we have fractions here. So I'm allowed to multiply each side by the LCM, which is a 2. So I'm going to multiply this side by 2 as long as I multiply the other side by a 2. So 2 times -5, that's going to give me this -10. And that's going to equal then, remember, the 2 is going to go into 2 and to cancel that out. And that's just going to leave me 1 times 3, which is 3. So this 2 is going to cancel with the 2 in the denominator and just leave me that 3. But I still got to multiply the 2 times the b. So I'm going to have plus then this 2b. Now to get b by itself, the 3's got to 0 out. So I need to move a -3 over there on the other side. So it's going to give me this -13 equals this 2b. And then I need to get rid of this coefficient of 2. So I'm going to divide both sides by 2. So that's going to give me this -13/2 equals b. So when I write my equation, I'm going to have this y equals, and I'm going to replace m with 1/2 x, and then my b is a -13/2. So that's going to be a -13/2 for your y-intercept. And so that would be your equation in slope-intercept form. So if you're given a slope and a point, we can replace m with the slope, but the point has to go in for x and y, which allows us to solve for b. So we get to use our solving linear equations strategy that we did back there a few lessons ago. So sometimes we may be given an equation in the form of 2x plus 5y equals, say, -10. And what they want us to do is they want us to write it in slope-intercept form. So to do this, if we want to rewrite the equation in slope-intercept form, our strategy is to solve for y. So, because remember, slope-intercept form is in the form of y equals mx plus b. So in other words, I have to get y by itself. So I'm going to rewrite this equation over 2x plus this 5y equals -10. So notice how the 2x has got to 0 out. So I put a -2x there, as long as I put a -2x on the other side. Or remember, if you move it to the other side, it just changes signs. So what I have is 5y. And since -10 and -2x are not like terms, we just bring those down, -2x and that -10. Now to get rid of the coefficient of y, we divide each side by 5. So the 5's divide out, and we have now y equals this -2x minus 10 over 5. What's a good idea is to go ahead and break it apart into 2 separate fractions. So we have y equals -2/5 x minus then this 10 over 5. So we separate it. And notice how the -2/5 x, really nothing to do there, but the 10 over 5 can be changed to a 2. So our final answer would be y equals -2/5 x minus 2. That would be our slope-intercept form. So we could graph it with that information. We would know that the y-intercept is -2, and then we can use the slope of -2/5 to locate a second solution and graph it. Another thing we're going to be coming across are horizontal and vertical lines. A horizontal line is going to take on the form of y equals b. So notice how there's not going to be a coefficient of x. It's just going to have the y-intercept in the problem. So if I give you the example y equals 4, what we have is, like I said, in slope-intercept form, it's going to be y equals mx plus b. But notice how, since the x is gone, that means that the coefficient x must be 0. But notice how the b was a positive 4. So we have this 4 here. So notice how we have a slope of 0 and a y-intercept of 1. Now remember, slope is a rate of change. So notice how there's a 0 over actually a 1, if you will. So there is no rise, there's only run. Now, if I want to make a table, you can put 2 into the problem, but when you multiply by 0, it just turns into 0. And when you add 4, you get 4. If you put 3 into the problem, you get 0 times 3, which is still 0. If you add 4, you still get 4. So notice how y is going to be 4. So if you put 4 in, you're still going to get 4. So those would be my ordered pairs: 2, 4, 3, 4, and 4, 4. So notice how the x's are changing, but the y's are not. So that's why the numerator is 0. So if I want to graph this, so as I said, we order pairs where when we put 0 in, we got 4. If we put 1 in, we got 4. We had 2, we got 4. I think we had 3, we got 4, and I think we had 4, we got 4. So I think I wrote down more than what we had up there. I think we just had these 3 order pairs. But it doesn't matter what x is, it's still going to be 4. So you have 2, 4, 3, 4, 4, 4. Notice how the line is horizontal. So notice how if you use m equals 0 or 0 over 1, notice that there is no rise, there's only run. It's only moving left and right. So no rise, run. No rise, run. So, and again, notice how b was 4. So that actually told us to start over here at the y-intercept of 4 and run, run, run with no rise. And that makes a horizontal line. So keep in mind, if you have y equal to a number, if you can memorize that, that's just going to represent a horizontal line. So now, again, as we said, the slope is 0, the y-intercept is 4, and we can sketch it that way. Now, a vertical line will take on the form of x equals a. So notice how y is going to be missing. If y is missing, we cannot write this in slope-intercept form. So y cannot be 0. It won't work for slope-intercept form. We'll talk about something else that also makes this not in slope-intercept form. So if I give you the equation x equals 2, what this basically means is x can be 2 and y can be whatever it wants. So if you want y to be 1, y can be 1. X has to be 2, but y can be whatever it wants. So if you want y to be 2, that's fine. X has to be 2. Y does not have to be restricted, so it can be a 3. So if you notice, there is a change in the y. There's a 1. But notice that there is not a change in the x's. That's a 0. And remember, this is where we get this division error. This is what we call undefined. Remember how we did that when there was 0 in the denominator. We also maybe refer to this as no slope. And since there's not a slope, we can't write a slope-intercept form. So that kind of comes across that way. So the slope is described as no slope or undefined slope. When this happens, this is going to show us is we're going to have kind of more of a vertical line graph. So if I come over here to the graph x equals 2, notice x equals 2, there is rise, but you cannot move left or right. So what happens here is this creates what we call a vertical line. So x equals 2. And that is, like I said, since I can't write it in slope-intercept form, this actually represents something that's not a function. So this is not a linear function. in this case here, because to have a linear function, you have to have a slope and a y-intercept, and we don't. Notice it doesn't even cross the y-axis. It's parallel to the y-axis, so it has neither a slope or a y-intercept in this case. So if you have an equation involving just x, we're going to recognize that that's going to be a vertical line. Now, some equations are going to be written in the form of ax plus b, y equals c. And what we're going to be asked to do is we're going to be asked to find the x-intercept and the y-intercept. So the x-intercept and the y-intercept are two special points. So the x-intercept is going to be a point on the x-axis, and the y-intercept is going to be a point on the y-axis. So if we're looking for an x-intercept, what we do is we set y equals 0, and we solve for x. If we're looking for the y-intercept, we set x equals 0, and we solve for y. So once again, to find the x-intercept, we're solving for x. So if I have this 2x minus this 3y is equal to 3. Notice when I set y equals 0, the negative 3y disappears. So all we have is this 2x equals 3. And so forth, we have x equals this 3/2 would be our y-intercept. If I set x equal to 0, notice that all we really have is when we have this 2x minus 3y is equal to 3. When we set x equals 0, the x term disappears. All we're left with is this negative 3y equals 3, because that x is going to 0 out that first term. And so if we solve for y, we're going to get y equals this 3 over negative 3, which actually turns into a negative 1. So that's going to be my y-intercept. So if I know the x-intercept and the y-intercept, I can sketch the graph. So notice that 3/2 is the same thing as 1.5. So I have to go halfway between 1 and 2. So that's going to be the x-intercept. The y-intercept we said was negative 1. So that's going to be here. And since I have those two solutions, I could sketch the graph of the line passing through those 2 points, and that would be the path of the line. Again, the line represents all the solutions. All we did was find 2 of the solutions, 2 of the ordered pairs, and that's all we need to do to represent the whole thing. So this kind of completes our lesson on working with lines. So the big takeaways is understanding the slope-intercept form of an equation and having an understanding of what a slope is and what a y-intercept is. Take care.